So in this video we're going to have a look at probability. First of all we're going to ask the question, what is probability? So it's a high probability, you've heard of this term before, and it is defined as the likelihood of an event occurring. So it's what are the chances of it happening, for example. So probability is expressed on a scale of 0 to 1. If the probability of an event is 0, it means it's not possible for this event to happen. For example, the probability of me getting a date with a supermodel is going to be 0. It's never going to happen, so the probability is equal to 0. However, if the probability is 1, this means that the event will occur. So the probability of me going and getting a bottle of beer when I finish making this video is 1. It's definitely going to happen, I know it is. It's a certainty. Probability can also be looked at as a percentage ranging from 0 to 100%. So if we use flipping a coin as an example to have a look at probability, we can work out the probability of it landing on either heads or tails. The coin will either land on with heads facing up or with tails facing up. There is the very small probability that the coin could land on its edge, but for this example we're going to ignore that there. Because the coin must land, and it's either going to land on heads or tails, the probability of it landing is 1. It's definitely going to land on either heads or tails. So this shows that there is going to be an outcome from flipping the coin. But if you were to predict an outcome, then you should know that the probability of heads is 0.5 or 50%, as is the probability of tails. So this is shown in this formula here. So P heads, probability of heads is 0.5, P for tails, or the probability for tails, is 0.5. This tells us that statistically, easy for me to say, you'll only be correct 50% of the time. So to display probability as an equation, it is simply the number of the desired or wanted outcomes divided by the number of possible outcomes. So as shown here, probability is the number of wanted outcomes over the number of possible outcomes. So for example, if you wanted to flip a coin and you wanted it to be heads, this gives us one desired outcome, and the number of possible outcomes is 2. So for the coin flip, for the possibility of heads, you've got one possible outcome that you want, which is heads, and you've got 2 possible outcomes together, that's heads and tails. So the fraction is 1 over 2, or a half, which is 50%, or 0.5. So if we're going to look at something slightly more complicated, rolling a dice, not much, well, rolling a die, sorry, not a dice, dice is 2. So let's imagine you're playing a board game. I know it's hard to. Let's pretend there's been a power cut. Can't play COD or Grand Theft Auto or whatever else you want to play. So you're about to win. It's neck and neck between you and your least favourite sibling. We all have a least favourite sibling. Mine's my brother. I hope he didn't watch this. So anyway, you need to roll a 6 to win, but what are the chances? Well, a die's got 6 sides, each with a value ranging from 1 to 6. So that's 6 possible outcomes. So you need a 6, which is only one desired outcome. So if we put that into the equation, moving along. So it's 1 over 6, because you've got one desired outcome over 6 possible outcomes, which gives you probability of 0.167, which is 16.7%. So you've got a 16.7% chance of rolling a 6 and winning the game. Now, if you're playing the same game using a pair, using a pair of dice rather than just the one, the probability of you scoring a 6 is going to be higher. So we know there are 6 possible outcomes for each dice, but this does not give us 12 outcomes for 2 dice. So there is 36 possible outcomes when you're using 2 dice. If you were to roll a 1 with the first die, you could potentially roll anything between a 1 and a 6 with the second. So the outcome for the first, there are 6 possible outcomes when you roll the first dice. When you roll the second, you have another 6 possible outcomes. So you're going to multiply that first 6 possible outcomes with the second 6. So that's going to give you the 36. So for each of the 6 outcomes, there's possible 6 for the second. So out of these 36 outcomes, 26 of them are going to be 6 or higher. This is because if you were to roll a 6 with the first die, then anything else you roll is going to be higher than a 6, meaning you're going to win the game. If you were to roll a 5 with the next, you either have to score a 6 or higher, you're going to need a 1 or higher, so you're definitely going to score a 6 or higher with the second die. For 4, you're going to need a 2 or above. 3, you're going to need a 3 or above. If you roll a 2, you're going to need a 4 or above. Roll a 5. If you roll a 1, you're going to need a 5 or a 6. So 6 times 6 is 36. So yeah, out of these 36, there are 26 possible for a 6 or higher. So we should have a much higher probability of rolling a 6 or above. So this is what it looks like in an equation. So it's 26 over 36, which gives us 0.722 rounded to 3 decimal places. It was recurring, the 2's at the end of that. So that is a 72.2% probability that you're going to get a 6 or higher, which is it's quite a lot different to the 16.7% I think you got from rolling one die. So when we take probability to look at probability and engineering, as engineers we often want to know the probability of things happening, like the probability that we're going to get a pay rise being one of them, or the probability of a part failing during use, especially if this is an essential part for the equipment or essential something you use quite regularly for operating or manufacturing parts. So you're not going to get an aircraft that's got a high probability of the wings falling off. You wouldn't buy a car that is statistically more likely to break down. I don't like the word statistically. I'm learning this. I can't say it. Yeah, you're not going to buy a car that's more likely to break down. So if you're purchasing from a supplier or manufacturer, you're going to, supplier. If you're purchasing from a supplier or a manufacturer, or if you're manufacturing parts, you want to know the probability of failure is going to be low. If anything, you want the probability of failure to be 0. So, damage from faulty parts are not only frustrating, but can cause damage and be very expensive if the equipment were to fail. So, understanding probability will help you in the future if you need to make important or potentially expensive decisions based upon it. So I'm going to look at milling cutters for an example. It's just a simple example that I thought of. So let's imagine your company started purchasing milling cutters from a different supplier. The previous supplier used to send the milling cutters in boxes of 60, and the probability of finding a damaged cutter is 0.2. So the new supplier sends boxes of 24. These on average have 3 cutters that are damaged per box. So which supplier is going to have the higher probability of sending a damaged cutter? So if you're going to go into the box and pull a milling cutter out, which box of cutters has a higher probability of having a damaged one in it? So which supplier are you going to use? So the probability of a broken cutter from the new supplier is shown here as 3 over 24, because it's 3 out of 24 that are going to be damaged, which is 12.5%. Or the probability is 0.125. So looking at that, the probability from the old supplier is going to be 0.2. You're going to get, 2 out of every 10 are going to be broken essentially, whereas this one is 3 out of every 24. So the probability of finding a broken tool is a lot lower from the new supplier. So you more likely to receive a broken cutter from the old suppliers. So summarise, the higher the probability, the more likely the event will occur. Probability is the number of outcomes you are looking for divided by the number of possible outcomes. So I've changed this because it does say the number of desired outcomes I said earlier, or the number of wanted outcomes. It's the number of possible outcomes. A broken cutter is not a desired outcome, but it is the outcome you're looking for. So it's the number of outcomes that you're looking for divided by the number of possible outcomes. So probability can be expressed as a percentage or as a number from 0 to 1. A probability of 0 tells us that the event is never going to happen, so that's 0%, there's no chance of it ever happening. And the probability of 1 tells us the event is certain to happen, so it's definitely going to happen, 100%, there's no avoiding it. So then the range in between of those two, if it's 0.5 it's a 50-50 chance, and so on. So it's all about the range in between the two. I hope that helps you out. So there's just a list of references here that I've used, so the images that I got and the engineering book by Thule that I've used to create this presentation. I hope that helps, and I hope you enjoyed the video.